Good day, great mind, watching my video outside there. I welcome you all again. And in case you are just coming to my YouTube page, as in this is the first time of coming here, do well to subscribe and turn on the notification bell. And don't forget to give a thumb up. And today I'll be showing you everything you need to know in implicit differentiation. But before that, let's see what we mean by the explicit differentiation. And if y equals to x squared plus x, so this example is an example of implicit differentiation. The reason is the y separates itself completely from x, and from the normal differentiation. So when we differentiate this, we obtain the derivative, that which is we differentiate with respect to s as dy dx equals to 2x plus 1. So you see that we are able to differentiate the x without any stress, and we call this one normal differentiation. Okay, for the case of implicit differentiation, so when the relationship between x and y is more involved, I mean both x and y, they really involve, as in the relation between them is closely. So it may not be possible to separate y completely on the side y falls the most. So this is the case of implicit differentiation. And to do this, for instance, let's say we have y squared plus x squared equals to sine x, and the second one to the third one, all this one they are example of implicit differentiation, because y and x they are more involved. All right. So now what are the steps to take for solving any question in this implicit differentiation? The first one is we differentiate both sides with respect to x, and then when differentiating a y term, we multiply by the derivative. So as in, if you have y and you are differentiating y, so you multiply that y with the derivatives. All right. So and for the second one, we solve for the derivative, which is the y dx, to get the y dx alone on one side. So after you have differentiated them, so you have attached the y dx to y, so you separate it. So let's see the first example, and this is the case where the chain rule is more necessary. So let's differentiate this. So we differentiate x squared, and we are going to differentiate y squared. But don't forget that when differentiating y squared, you add the y dx. All right. So differentiate 2x, we have 2x, and differentiating this, we are going to have 2y dy dx. All right, and the derivative of any constant value, that is 0. 16 is a constant here, we don't need it, that is 0. Okay, so the next thing is we have 2x and 2y the y dx, so we transfer 2x to that side. So we have 2y the y dx equals to minus 12. So it's positive, coming here change to negative. Then we divide both sides by 2y, that is the second stage. So make sure that the y dx separate itself. So by doing this, we are going to have the y dx. So having the y dx equals to if 2 cancel 2, so we have minus x divided by y. So here is the first example, and it's very simple as it looks. So let's see how we can solve another one. So for this one, we have xy with operation multiplication. All right. So this is the product rule of the product rule techniques of solving differentiation. So the first one is we keep the first one, we differentiate the second one with operation addition. When we keep x, we differentiate this, so that is 1. All right. Then but as far as the rules is still hold, so we multiply it with dy dx, and we keep y as well, we differentiate x, so that is 1. Okay, equals to 0. So the next thing is we have x dy dx and plus y equals to 0. So we transfer y to that side. So for us to have the y divided by the x equals to minus y, and then we divide x by both sides. So we have the y divided by the x equals to negative y divided by x. So it's very simple. So the question is product rule. So applying the implicit differentiation, so we got it. Okay, let's see example number 3. We have sine x plus sine y equals to d. So by differentiating sine x, we have cos, and if we differentiate sine y, we still have cos y dy dx. Don't forget, differentiating y in implicit, we attach the y dx to it. So we transfer cos to that side, cos x to that side. So we have cos y dy dx. Everything equals to negative cos of x. All right, and we need only divide the x. We divide both side by cos y, and by doing this, we have cos x divided by cos y, and x is the final answer for this. Okay, let's see the fourth examples. So here we are given the value of x and y, which after we have gotten the final answer, we substitute the value of x and the value of y. Okay, so we have y at this side, y at this side. So we differentiate y, that is 1, but don't forget the y, the x. Okay, equals to differentiating x squared, that is 2x, and we have this one as 2y, the y, the x. Okay, we have the y here and the y dx here. So we do the collection of the like term by taking this to this side, as in 2y to this side. Then we have negative 2y dy divided by the x equals to 2x. And this for the first dy is having 1, alright? So, and the y dx is common to both. We do the factorization by taking the y dx, we take it out. Taking it out, we are going to have 1 minus 2y equals to 2x. Alright, so we divide through by 1 minus 2y, then we have the y dx only equals to 2x divided by 1 minus 2y. Okay, and from this we have x equals to 3, y equals to 2. Alright, so we are going to substitute these two values in this. So by substituting these two values, we are going to have 2 multiplied by 3 divided by 1 minus 2 multiplied by 2 multiplied by 2, and the final answer becomes 6 divided by minus 3, and the answer is negative 2. All right, so A is the solution to this example, and then let's see the next one, which will be the last one. Okay, x squared minus xy plus y squared equals to 7. So to do this, we are going to differentiate x squared, that is 2x. Y is another product rule, so we keep x, we differentiate y, that is the y dx, since it is power of 1. And here is plus, we keep x, we differentiate y, so into bracket of 1. The reason why I open bracket is because of the negative to affect everything. Differentiating y squared, that is the y divided by the x equals to 0. So that is the derivative constant, which is 7, equals to 0. And here we are going to try and open the bracket. So here is negative x, the y divided by the x, everything negative y plus 2y, the y divided by the x equals to 0. After getting this, so we are going to take 2x and minus y together because they don't have the x, the y dx, and we also combine it. But I'm going to start with okay, let's see the y dx first, plus 2y dy divided by the x equals to 0. And the next thing is we take these 2y to that side, and here we combine these two together. Okay, but I'm going to start with positive first, so just to make my work very easy. So you write this one as 2x minus y, and plus, all right, plus 2y minus x dy dx equals to 0. And the next thing is by taking this one to that side, as in 2x minus y to other sides, and taking it to other sides, so we are going to have 2y minus x dy dx equals to minus open bracket 2x minus y. So don't forget, I've opened the bracket, so that is why the negative y doesn't change. So negative y outside there, so it's working for both. The final answer, which is the y dx, equals to negative 2x minus y, everything divided by 2y minus x. So here is the final answer, and it stops here. Okay, that will be the final answer for this, and the final question. And here is a task I provided for you, just to make sure that this concept is very, very clear. You solve this, you drop the answer in the comment section. I will attend to it, and don't forget to subscribe to my YouTube channel. Thank you very much.